Good morning, everyone. Welcome to CS3650 Computer Systems. I am Nat Tuck, and I'm teaching Section 1 and Section 3 of 3650 this semester. We're going to be doing a sort of hybrid or flipped style class this semester, where I'm going to be recording video lectures before the week starts, and then you'll watch the video lectures, and then you will optionally come to in-person meetings where we will do some demos that may be related to the course content, and then you'll have the opportunity to ask questions. Those in-person meetings will also be streamed over Zoom, so you can ask questions remotely if you want to. The meetings are entirely optional, but it's probably worth attending them once you have questions. One important thing about this course structure with video lectures and stuff, and that is that these video lectures won't be perfect. Producing a video lecture where I don't say over and over again and it's all properly edited is extremely time consuming and doesn't increase the value of the lecture content that much, so we won't be doing it. I'll be producing stuff with pauses in it, and I'll be stumbling over my words, but I'll try to make sure that the content is reasonably clearly expressed. So, CS3650 Computer Systems. What is this class about? This class is about concrete computer systems and how to write computer programs that will run on those computer systems. In this class, we usually have two groups of people. We have people who are computer science majors, and we have people who are from the College of Engineering. I'm not entirely sure how the people from the College of Engineering manage to learn how to program. I haven't really paid attention to the curriculum there, but usually the engineering people are fine and figure stuff out. The people from computer science have usually gotten here by doing Fundies 1 and then Fundies 2. And in Fundies 1, you definitely pretend there is no such thing as a concrete computer. You're working with this sort of abstract mathematical model and trying to pretend that things like amount of memory or like actually having a hard drive or processors or whatever just aren't even there. You're just trying to run this abstract program on an abstract imaginary machine. In Fundies 2, it gets a little bit closer to admitting that there's a real computer, but you're still running on the Java virtual machine, which sort of abstracts away the physical machine. In this class, we're going to definitely admit that there is a physical machine and that it's running concrete software. Now, let me find my marker. I think I lost it. And a wipey thing. So when I talk about a concrete computer system, I'm talking about two components. The first thing I'm talking about is an instruction set architecture. And that is what kind of processor do we have in the computer? For example, we might have a processor from Intel, an Intel Core i7 4770K. That's a specific processor. But actually it turns out that if we have a Intel Core i7 4770K, that's basically the same as if we had a Core i5 6550. From the perspective of what software we can run, it's basically the same. There might be slightly newer, there might be a new instruction that programs are able to use in the newer processor. The Core i5 might have a few less processor cores than the Core i7 did, but for simple programs, they have the same set of instructions that they can execute, and the computer system as a whole is structured the same way. They are the same instruction set architecture. So we have to pick a instruction set architecture that we're going to focus on, and we have a couple of options. The first one is that Intel architecture that I was just talking about. So that's the modern version of that architecture is called AMD 64. And it is the instruction set architecture that's used on almost all modern desktop and laptop computers. It's produced by a couple of companies. It's produced by Intel, it's produced by AMD, and it's produced by whoever the descendant of VIA is nowadays. Probably nobody has the descendant of VIA processor unless you were buying relatively slow locally produced processors in China in the past 9 months. They hadn't made processors before that for a decade, But those are the companies that can produce AMD 64 architecture processors because of licensing reasons. Another thing that might be the option is an ARM instruction set architecture. There's a couple of them that people use. The 64-bit current version is the one that is common in modern cell phones and some tablets. And then, other than these two, there's a couple others. IBM has PowerPC, which is a modern instruction set architecture. It's still possible to get machines that are the MIPS instruction set architecture, which is mostly just routers that you'll find it in nowadays, or special purpose embedded machines. But you don't have a MIPS machine, so it's no fun to force you to use MIPS. We did use MIPS as one of our targets in previous semesters because the assembly language for it's really simple, but it's better to use something that you actually have, I think, at least right now. That's my opinion today. We're not going to do PPC because PowerPC machines are expensive and sort of obscure. They're nice, but they're expensive and obscure. So that leaves desktops or cell phones. Now we want to be able to run code directly on these machines. And so we want to pick something where doing that is easy. And unfortunately, a lot of people have cell phones where running arbitrary code on them really isn't even supported. Specifically, running arbitrary code on Apple devices requires that you have a Apple developer account. You have to go through some hoops. You can't really write code and then let someone else run it without publishing it on the App Store. It's a mess. Unless we're going to decide to show you how to jailbreak your iPhone and then install some alternate operating system on it, which I'm not even sure is straightforward or possible on all of the iPhone devices. Everybody has a cell phone, but we can't really program those cell phones reliably. So that leaves your desktop or laptop computer. Pretty much everybody has a laptop. It's almost certainly AMD 64. So that's what we're going to do for our instruction set architecture to talk about this semester. The other component of a computer system is an operating system. I'm just going to write OS. We have a couple options there too. We could do Mac OS. How many people don't have a Mac? Everybody raised their hand except for 40% of people probably didn't raise their hand and are annoyed at me because I thought that nobody had a Mac. But half the class doesn't have a Mac. I don't have a Mac. And installing Mac OS on a machine that isn't a Mac isn't really feasible, so we're not doing that. Another common option is Microsoft Windows. So 45% of the class is going to have Microsoft Windows, and that's another option, but dual booting Windows on a Mac is sort of obnoxious. That's no fun. So we do have another option, and that is one of the Linux family of operating systems. There's a couple other operating systems that exist, but they're not as common. And Linux has two big advantages. Advantage one, it costs $0. You can just download it and install it either directly on your machine or in a virtual machine. So that's nice. Windows costs money. Mac OS costs money and is hard to get other than through a Mac. And the other advantage to Linux is that it's open source, which means that you can go download the complete source code for the operating system. And if you want to know how something works, you can just go look, and that's pretty amazing. So we're gonna use Linux since it has those two advantages. Specifically, we're going to use the Debian release of Linux version 10 as our target operating system for this semester. You could potentially use some other version of Linux. It's probably about the same, but since we want to talk about a concrete computer system to be able to cover the material in the class, the concrete computer system that we're talking about is a AMD 64 architecture machine running Debian 10. And that is a computer platform or a computer system. So that's what we're going to be talking about this semester, is what can you, as somebody who's writing computer programs, get out of your machine given that your machine is running a concrete instruction set architecture. You have some specific processor that executes some specific set of instructions, and you have a specific operating system that executes some specific set of system calls. That's the operating system interface that lets you get the operating system to do stuff for you. yeah, so that's what we're doing this semester, and I'll come back in the next video with how we're gonna do it. How's the class going to run? Right, one more thing. Why do we need an operating system? So on a modern computer, you want to be able to run more than one computer program at a time, and that's a complication. Back in the day, if we got a desktop computer in 1982, we'd only have to run one program at a time. That makes things easy. If a program wants to print something to the computer screen, it can go ahead and connect directly to the computer screen and tell the computer screen to do the thing. If it wants to read input from the keyboard, it can go ahead and use whatever interface, be it a library or a direct access to hardware, however that works, lets it talk to the keyboard and it can say, send me the next character. With one program running at a time, no problem. If you have two programs running at a time, that gets you into a situation where you have to ask, if both of them try to read from the keyboard at the same time by directly asking the hardware, what's even gonna happen? Probably it's gonna break. We're gonna get some screwy behavior where one of them gets the input or both of them get the input at the same time, but we only meant it to go to one of them. So that's no good. So what an operating system does, among some other things, is it allows us to have control of access to shared resources like hardware, like that keyboard. So instead of reading from the keyboard hardware directly, we ask the operating system, can you get me some key presses from the keyboard? And the operating system will either say, sure, here's your key presses, or it will say there are no key presses, but it will say that not because there are no key presses, but because it's giving those key presses to someone else. And that makes sense. Like you have some window selected and not the other one. And so the window you have selected gets the key presses. We also have some other shared resources that the operating system is going to manage. For example, files. You might save an image from a web browser to a file on disk, and then you might want to open that in an image editor, and the operating system is going to provide the interface that lets you access files. So that's why we have operating systems, and that's the sort of thing that we'll be dealing with. That interface that the operating system provides that lets us do that is system calls.